Hello, this new presentation about Istio digs into distributed traces, a part that is based on OpenTracing. It will be answering some key questions like what it is, how it works, and what you can get from it. And like in the two previous presentations, it will also include a short demonstration. So this time, it relies on a project of my own I've called Recursed, and you can get from my GitHub repositories. If you are interested, have a look at the link below. Do not hesitate to use them together. You'll better understand what you can get from Istio and OpenTracing. And now, let's go for it. Understand how your application is working can be very hard. It is especially true if you are working with a microservice architecture and if you are updating your components frequently. On the other hand, we are all being told that this is something we should be looking for. So to help you, Istio comes with a set of tools that helps observability in the three areas that are monitoring, logging, and tracing. First, the monitoring side. Istio generates metrics that you can collect with Prometheus. It also comes with a set of predefined dashboards that you can access from Graph. Next comes the logging. Here again, you get some tools, so you can set up FluentD to collect logs, and you can also send those logs in a centralized service like Elasticsearch. In those two cases, what you are doing is looking at component one by one. In the case of microservice architecture, you might be very interested at looking at the chain of calls and how components are behaving altogether. You might want to understand how a failure on a service A can impact service B. That is where distributed traces can really help. As a matter of fact, that is what it is about. How to coordinate the collection of calls between services starting from a request or starting from a user. How to report those directed acyclic graphs of calls in a specialized repository, and how to get tools to understand how your application is working. That is what OpenTracing is about. Plus, it supports a number of languages and frameworks, and it does it in a way that you can have different backend services that are compatible and comes from different providers or even from an open source solution. Now, let's have a look at the detailed architecture of OpenTracing. OpenTracing includes a model of traces as well as some details about how things should work and especially on how data should be propagated between processes, threads, and remote services. It's not a standard per se, but it's a set of conventions and tools to help people to get to compatible implementations of the tracing model. Let's talk about the core concept. The first concept is the concept of a span. It covers a set of instructions, usually in the same process. It has a start and it has an end, and you can decorate it with tags or logs that are private to the span. A span can have child spans or a follow-up span. A span context is a way of sharing data between spans. For traces to work, the context must include some data, like the parent span ID. It must also store some information, like the fact that the span should be collected, so that in the repository you can review the whole graph of calls for a given request. Span context can also be injected and extracted as part of a remote procedure call, like an HTTP call or gRPC call. You can add data to the span context, and they will be propagated to all the childs and following spans. Those data are held by what we call packages. All those data, they are reported to the repository. It collects them and links them together to provide the consolidated view of your traces. So that's pretty simple, but because it's happening inside of your program, it has to be coded by your developer, or at least by your framework. Anyway, the point is that it does not come for free. Now that we've seen how it works in general, let's look at how it works in Istio. In the case of Istio, a span is generated by Envoy every time it is crossed by remote procedure call. So a span is generated when the request enters the mesh via the gateway, for instance, and a child span is also generated every time a request enters a pod. To be able to trace the directed acyclic graph of calls, the application must maintain the link between the request it gets and the calls it does. The way to do that is simply by propagating a set of headers that are the Zipkin headers, starting with x-b3- something, and the x-request-id header, that is the header of the request entering the mesh. So basically, all you need to do to benefit from OpenTracing in an Istio mesh is to extract and re-inject those headers that are coming from the request into the subsequent calls. Depending on the case, Envoy directly or indirectly pushes the traces to the OpenTracing backend. The current version of Istio supports Jaeger, Zipkin, and XPM. Obviously, there are some limits to the implementation, and for instance, you cannot decompose what is happening inside your service simply because OpenTracing actually doesn't work in there, but instead it works in Envoy. You cannot either decorate your span, and that's exactly for the same reason. That is, the span is actually as part of Envoy, not as part of your service. So if you want to overcome that limit, you can probably implement your own OpenTracing collection inside of your services and push them to an agent of your own. But on the bright side, the cost of using OpenTracing with Istio is very light. Let's look at how it works with a quick demonstration. So in this demonstration, we will use OpenTracing with a service. The service is called Recursed. We'll look at the manifest. It is actually a Kubernetes service. It's called Recursed, and it will point to a deployment that has a container. You can get the container there. It's also listening port 8000. You'll see the virtual service pointing to there. So we're good. We will install it. Kube control, apply the manifest. We'll should be able to see the pods. If you're interested, you can get the repository there. It has two installation sets. One is with Docker Compose. The one we are interested in is Istio. We will look at the gateway name. So just run this command, you'll get the gateway name. In the case of AKS, just set up that gateway. Then we should be able to request the service with this command. So it's a recursion, as the name suggests. Here we run six recursions. We will change that to 9, and there is a slight delay. Right, so we'll see the timing. We'll run the time before the curl. You'll see it takes a little bit more than 2 seconds. So now we can connect to the console. We'll create a tunnel. Here we are. We should be able to connect to our brother to the console. We have a link here. And you just create a service. So go to the bottom of it, just find the service. You'll see a map with the query here. You'll see all the different services. You can just click in there. You'll see the recursions of those services, and you'll see the one that is taking some time. You can look at the time and the detail of it to understand what is happening. That's it. You can stop it, clear the console. We're done. Let's summarize what we've seen in this presentation. Istio implements OpenTracing out of the box. So installing it is simple. It only requires you set few options during the installation, even if you might want to customize it to scale it to a larger environment. It's also easy to implement. All you have to do is to propagate headers that are coming from requests into subsequent calls, and it's cost effective. We've also seen that some options are not available, like logs or tags, but you can always use a custom implementation of OpenTracing if you want. If you want to go further, you can always inject some baggages and use them not only for tracing, but also for more advanced scenarios like passing the caller identity to a backend service or route traffic inside your mesh. We'll continue the series about Istio next week, so stay tuned. In the meantime, if you like that video, do not hesitate to subscribe to the channel or leave a comment, and see you soon.